What if Einstein were wrong? In his book titled Special and General Theory of Relativity, Einstein affirms that it is impossible to choose a body of reference such as the gravitational field of the Earth vanishes. He meant it is impossible to find a reference such as the gravitational field of the Earth be wholly translated in terms of acceleration. Einstein was trying to explain the cause of gravitation as being in our cosmos. Maybe the answer lies in a greater reality, the multiverse, which includes our visible cosmos and the invisible ones. Ancient Egyptians spoke of the earth and 7 heavens, and this has been included in a greater reality, which is the consciousness of the Creator. We have shown that perception of things is scientific and demonstrable. Let's show these things hierarchically and schematically. Let this be the absolute space-time, which corresponds to the consciousness of the Creator as including all the other space-time. We have here the relative space-time, which is our cosmos. And beyond, we have other space-times, which are the heavens of the Egyptian. Let's consider a segment AB in the relative space-time as belonging to the absolute space-time. AB is called capital R. Has seen as belonging to the relative space-time, AB is little r. Now, the question is, what is the influence of the acceleration of the absolute space-time on the segment R? We have demonstrated that the absolute space-time accelerates toward 0 because the multiverse is a temporal reality, while the relative space-time accelerates toward infinity, but this acceleration is so small as to be negligible. So the only remaining question is, what is the result of the acceleration of the absolute space-time on the segment AB? We have 2 things to consider. First of all, we have to express the acceleration of R when AST accelerates toward 0. That is, R accelerates also toward 0. This is the first thing. The second thing is that R belongs to the absolute space-time, or we can say to the relative space-time. Both are correct. So we have to express that R belongs to the relative space-time. By combining these two conditions, we will have the explanation of gravitation. We know that at the initial moment we have R equal R. As time elapses, capital R accelerates towards zero, as seen by an observer placed on B. R loses the distance K. This means that as R is dwindling, K is growing. So the situation becomes R equal R minus K. Now we can write K as a factor of R by posing K equal R times D. The equation becomes R equal R minus RD. This means that since little r is constant, when R dwindles, D grows, D accelerates, and this acceleration this movement of D is rectilinear and constant. So we know that the equation of such movement is D equal D0 V0 T half G square T. The initial distance being null, the initial velocity being null, we have D equal half G square T. So the equation becomes R equal R minus R half G square T. We don't know the time of the absolute space-time, but we know the time of the relative space-time, which is our cosmos. So we can derive 2 times this equation and find the acceleration of R according to the time of our cosmos. The first derivation yields the velocity, which is V equal, this become null, and we have there minus RJT. The second derivation yields the acceleration, which is A equal minus RG. This is equation 3. Now, we will express the second condition, that R belongs to RST, to the relative space-time. We have V equal H square R. This is a volume of the relative space-time, but we know that the relative space-time is included in the absolute space-time. So this is also a volume of the absolute space-time. We can write H as a factor of R, and we will have H equal PR, and V becomes P, R, and square R. Now, the exact size of V doesn't matter. The important thing is that V must be different from 0. So we can take V as be equal to P times a constant C. Then this equation becomes P C equals P R squared R, or P R squared R equals P C. By simplifying the value P and by dividing the two members of this equation by square R, it remains R equal C divided by square R. This is equation 4. By combining the equation 4 and the equation 3, we will replace the value of R by that value. We will have A equal minus C R multiplied by J. We can pose that minus C G equals J, because we know that J is constant and C is constant. Then it will yield the constant J. What we have now is A equals J divided by square R. If we consider A and B as being two bodies of our cosmos having the masses M, capital M and small m, we will have A times M equal J M divided by square R. This scalar multiplied by this scalar yields a scalar which is a mass, and multiplied by the acceleration we have a force which is equal to J M. Remember, this is Newton's law of gravitation. So the question is, how an easy problem of high school has been turned into a quandary of high-level academic? My answer is Einstein was wrong. If you want to delve more on this subject, you can find the books of Dr. Rialuka on www.amazon.com, and especially the one titled The Theocentric Big Bang Cosmology. Thank you.